Welcome to All This Math. This is Professor Parker, and today we're going to talk about trig ratios. Okay? Trig ratios, you probably heard of it before. You probably heard, SOH-CAH-TOA. You might be wondering, like, well, what does SO mean? What is SO? What is CAH? What is TOA? Right? SO deals with sine, the sine function. CAH deals with the cosine function. TOA deals with the tangent function. And before I go on, I do want to spend a shout out. Let me try that again. Before I go on, I do want to send a shout out to my cousin Kennedy down in Georgia because she actually sent these problems in. So, I'm creating this video for her, right? So I appreciate that, Kennedy. Thank you. All right. And back to what I was saying about SOH-CAH-TOA, right? SOH-CAH-TOA, sine, cosine, tangent. It deals with, relationships between the different legs or the different sides of right triangles, right? So if you look at number one, we know this is a right triangle because it has a right angle or a 90-degree angle, right? You see this box in the corner? This means that this is a 90-degree angle. You know that this is a right triangle because it also has a 90-degree angle or a right angle, okay? So how do we use these trig ratios? How do we use them, okay? First thing you want to do is you want to look inside the triangle. You look for an angle, right? But you don't want to use the 90-degree angle. You don't want to use that. You want to use one of the other two angles. Now, we know that this angle is 25 degrees because it's labeled that way. Now, you also can figure out what the measure of this angle is because you know the triangle sum theorem. The triangle sum theorem says that all three angles inside any triangle must add up to 180 degrees. So if you know that this is 90 and you know that this is 25, we know that that adds up to 115. So if that adds up, these two add up to 115, then this other one must be, what, 65 degrees? Yeah, 115 plus 65 is 180, right? So that will be 65, but you don't need to worry about that. You don't need to do that. You can just deal with the 25 degrees that you're given. So if we deal with the 25 degrees that we're given, right? Because the first step, when we're ever dealing with trig ratios or trying to find a missing leg or even a missing angle, right? Well, not a missing angle, but if we're just trying to find a missing leg or a missing side in a right triangle, we want to start with an angle. So once I start with that angle, then I look at the other information that I know, and I look at the information that I'm trying to find out. All right? Because we kind of got to take an inventory of what information we have and what information we need to figure out. See this X right here? This is the missing leg, right? Instructions say to find the length of the missing leg, right? So now, next question is, how does this leg relate to this 25-degree angle? That leg is adjacent to that 25-degree angle, meaning it's next to it, right? So X is adjacent. So you want to either make a mental note of that or you want to write that down on your paper. This side right here is adjacent to the 25-degree angle. Then you want to look at the triangle further and say, okay, well, what else do I know? Okay, I see this is 65. And I said, well, what side is this? This is called the hypotenuse. Now, how do I know that that's the hypotenuse? I know that that's the hypotenuse because the hypotenuse, yeah, it could be, a lot to say, right? Hypotenuse, right? The hypotenuse is always across from the right angle. So you see the right angle is right here. Hypotenuse is across from it. Right angle, hypotenuse. Right angle, hypotenuse. Hypotenuse, right angle, right? They're always across from each other, right? So we know the hypotenuse. Now again, make a mental note or write these down because this is going to tell us, sorry, I had to make an adjustment real quick. All right. This is going to tell us which trig ratio we should use, okay? If we know the adjacent leg or we're trying to find the adjacent leg and we know the hypotenuse, if we either know or we're trying to figure out these two pieces of information, then we're going to use the cosine function. We're going to use the cosine function. And that's the CAH part of SOH-CAH-TOA. SOH-CAH-TOA. CAH, C-A-H, right? Cosine equals adjacent, that's the A, divided by hypotenuse, that's the H, all right? A-H, all right? So this is how we set up our equation. We set up our equation like this. Cosine of the angle 25 is equal to the adjacent leg, which is X, divided by not multiplied by, but divided by whatever the hypotenuse is. In this case, it's 65. This is our equation. Cosine of 25 degrees is equal to x divided by 65. So that's our equation, right? That's, the most difficult part, setting up the equation. Once you set up the equation, now we're back to algebra 1, right? Just using our algebra 1 skills. So you could either evaluate cosine of 25 using your calculator, right? Basically, right? You could do that first, or you could just cross multiply first. Because remember, this is a fraction. And this, while this is not a fraction, I can make it look like a fraction by just doing this. Boom. Now it looks like a fraction. So then I cross multiply. All right. I rewrite the equation. Cosine of 25 times 65 is equal to x times 1, which is just x. So the cosine of 25, I pull my calculator out if I don't have it out already. And I'm checking my notes because I did this problem already, right? So cosine of 25 is, and I rounded to the fourth decimal place, so 0.9912, and then times 65 equals x, right? And then I multiply these two numbers together, and I get something like 64.43, and that equals x. And that's our final answer. And this is a reasonable answer because another thing you got to remember is that in a right triangle, the hypotenuse is always the longest side. The hypotenuse is always the longest side. So if you ever get an answer, if you're dealing with a right triangle, and you ever have a situation where you calculate the hypotenuse or you calculate one of the other legs and the hypotenuse is not the longest side, you need to go back to the drawing board and check your work. All right? So x is 64.43 for number 1. All right? Now let's look at number 2. Number 2, again, we follow the same steps. We know this is a right triangle. We already said that. We look for an angle. I see a 35-degree angle right there. All right? But now I'm thinking, okay, well, which trig ratio am I going to use? Am I going to use sine, cosine, or tangent? What am I going to use? So then I look at it and I see, okay, well, what information do I know? I know that I know the length of this side right here. It's 10 feet. And I know I don't know the length of this side, and this is what I need to find out. So I don't know the side that is opposite the 35-degree angle, opposite the 35-degree angle because it's across from it. Opposite meaning across from it, right? Just like the hypotenuse is across from the right angle. And I know the adjacent leg. Just like in the last problem, we were looking for the adjacent leg. I know the adjacent leg. And I'm looking for the opposite leg. So I'm looking for the opposite leg, and I know the adjacent leg. So now I got to ask myself, which trig ratio deals with opposite and adjacent? It's not sine, and it's not cosine. Therefore, it must be tangent. Tangent, that's the TOA. The TOA in SOH-CAH-TOA. Tangent equals opposite divided by adjacent. So we set up our work. We're going to say the tangent of 35 is equal to the opposite side, which is x, which we don't know, divided by the adjacent side, which is 10, which we do know. Got that right there. And basically to solve for x, we're going to do the same thing we did in the first problem. I can make this look like a fraction, put a 1 underneath, cross multiply. I got 10 tangent 35 times 10 is equal to x. Tangent 35 times 10 is equal to x. And then my tangent 35, I calculate that to be 0.4738. And then I multiply that by 10. And I know the tricks of, multiplying by 10 or base 10 or 10, 100,000, any number that is a power of 10. I don't need a calculator for that because if you multiply by 10, all you're really doing is moving the decimal point one space to the right. So this is going to be basically 4.7 equals x. I mean, you could write 4.738 if you want to, but we round off to the tenths place. It's cool. Or if you want to be consistent, you know, in the last problem, we rounded to 2 decimal places. So I guess we could do that. So we could say 4.74. That's cool. And that's the length of this. Now, something else I want to say about drawings. This drawing is clearly not to scale, right? Because how could this side be 10 feet and this side be 4.74? That's wild. But that's why when we're dealing with geometry or we're dealing with trigonometry, we don't judge drawings by how they look, right? We follow the numbers. We deal with the numbers. That's what we do. We deal with the numbers. All right? So that's basically, I mean, that's how we use the trig functions. I mean, sorry we didn't get to use sine. We use cosine and we use tangent. Sine might feel left out. We ain't use sine today. It's cool. I'll do some other videos where we use sine. All right? But if you're watching this and you have not already, please subscribe to the page. Please share the videos. Share the wealth. Let some other people know, about all this math. All right? And as I always say, please do remember that there's all this math all around you. Peace.